Hello, everyone. So I will talk about how we actually use the complete square to get the quadratic formula, okay? So, but before we do this, this is our standard formula of quadratic. So we have the ABCs like the as the coefficient, right? But just for a like maybe heads up, I'll just remind the steps that we use to complete square. So for example, if I have, let's say, x squared for x, and then let's say plus 5 equals 0. Maybe I can do make it a better number. Let's say this is 3 equals 0, right? So this is a quadratic where the coefficient of the square term is 1, the linear coefficient is 4, the constant is 3. So I can use a couple of different techniques, like maybe factoring, and if I know the quadratic formula, I can use, or I can complete a square. But I'm assuming that we don't know the quadratic formula. I'm going to just use the complete square to get it, actually. But just as a reminder, whenever you are trying to complete a square, you need to have this coefficient to be 1, which is in this case 1. And then you take the half of this guy, right? So you take the half of 4, which is the coefficient of the linear term, and you square it, right? Which is going to be 2 squared, which is 4. So to do the complete square, so you need to add this number to this term. So that would be x squared plus 4x. And you are adding this number after the linear term, that's 4. And there is like there is a plus 3, but since we changed the question by adding 4, I'm gonna either subtract 4 and leave my 3 after, is equal to 0. Or instead of subtracting 4 right here, maybe I could just add 4 to the other side so you can the equation same. But I just add 4 and subtract 4. So if you are wondering why I'm doing this, because I like to get a 3 terms, so that could be a perfect square. And if you are not really familiar with this, maybe it's better to review those steps that we use to complete square, and maybe review the square of binomial as well. But this is just as a reminder, so it's not complete um, lesson basically on the complete square. So these three terms are like is a perfect like trinomial, so which can be written as x plus 2 to the second power. And then you have 3n minus 4, which is just -1. If you add 1 to both sides, so you get equals 1. So if you don't really see how these three terms is actually the same as this one, then you really need to review this before you move on to this one, to be honest, okay? But now, I'm assuming you are all good with these steps, and then this is what we use to complete square, and the rest just solve this equation for x by taking square root and stuff. But I'm gonna stop here, so let's get back to this problem. So the question is a quadratic where a, b, c are not just random values, okay? Just unknowns, any number. And but to complete a square, I need to have the coefficient to be 1, but that's not. So which is why I will divide both sides of the equation by a. Okay, so if I divide this by a, then I can divide this by a as well. So then a divided by a will be just 1, so that will be x squared. And then b divided by a is b over a, and then that's going to be x plus c over a, and it's equal to 0. Okay, so now this is 1, which is something like this. The next step was we take the coefficient of the linear term, which was 4 in this case, and we divide by 2. But the coefficient of the linear term is b over a, which is why I'm going to take that and then divide this by 2. Okay, and as soon as you do this, you take the square of this quantity. B over a divided by 2 is b over 2a. If you square it, so you will get b squared over 4a squared. So b over 2a times b over 2a will be just b squared over 4a squared. So which is something I should be adding right there. So let me do that. X squared plus b over a x. And I will add this term, which would be my second perfect square term, for a square. And then there was c over a, but since I'm going to use only these three terms, maybe I shouldn't be caring this much. But I will leave it for now. because otherwise it will be a bit confusion for some of us. So that will be C over A. But I change the equation when I add this red expression to the left side because this was 3 terms, but now I have 4 terms. So I cannot do that without adding the same to the other side. So again, you could have just subtract this whole thing from itself. So instead of adding this to the right, at the end of the day, I'm gonna just move all these terms except the first 3 to the right side of the equation anyway. So which is why it's better to write it here anyway at this point. So then I may subtract C over A from both sides, and then I can rewrite these 3 terms. Again, this is a perfect square because if you take the square root of x, that will be, x squared, that will be just x. And then the square root of this was b over 2a, because that's how we got it, that b squared over 4a squared, when you take the square of this fraction, which was b over 2a. So that is why I can replace as b over 2a added to x, and that is squared. So if you expand this, you actually get these 3 terms. Okay. And then if you subtract c over a from both sides, so you will get c over a plus b squared over 4a squared. Okay, so I hope that's clear so far. If there's a question till this point, so I highly recommend you just go back and do step by step before you really go further. So let me take this out of the way. Okay, so we got this, but our goal is to get the x itself. We are looking for a solution for this quadratic. But there is a mess right here where we have 2 different denominators. Maybe it's better to make them like same. So by multiplying maybe this fraction by something to get the same number right here. So maybe I can multiply this by 4a. And then I can multiply this by 4a as well, because if I do so, that will be 4a times a, which is 4a squared, which is the same denominator, which is the goal. And the left side is the same, x plus b over 2a to the second power. And the right side, we have b squared, and then that's c times 4a, but there's a minus, so that means this is minus 4ac. So I can write minus 4ac, and then plus b squared over 4a squared. Okay, so we are almost there. So I'm gonna drag it right there. So we have a fraction is equal to square number. And then since we want to get this x alone, I'd like to get rid of this square, and then I'd like to get rid of this b over 2a as well. So then I can take the square root of both sides. Okay, so that would be x plus b over 2a is equal to, like, I'm going to rewrite the numerator in a way that b squared will be my first term, so I can just do that. B squared minus 4ac, that is under square root, over, but when you take the square root of the equation, you want to make sure there is a plus and minus version of that, because you can square this to get this expression, or you can just get a negative version of that squared, so you'll get the same thing. And then if you take the square root of this denominator, so this was 2a times 2a, which is a 2a squared. So if you take the square root of 4a squared, that will be just 2a, so then there's no radical left, which is nice. But that is x plus b over 2a. So my final goal is just to get this x alone. So I can subtract b over 2a from both sides. So that will be minus b over 2a on the right. And then plus and minus b squared minus 4ac over 2a. Okay, and then this is called quadratic formula, because as you see, we got the x alone in terms of ABC. ABC is the number in front of those x's, or my constant term. So, and then this is called quadratic formula. So most of us already seen this before, but if this is the first time, it is actually how we derive this formula by using complete square. So which is why I like complete square compared to quadratic formula, because I can do complete square for anything to get a solution, even itself like quadratic formula. Okay, so I hope that makes sense. And if you like to use like some example just to see how you apply them, maybe we can do that as well. But for example, if I have 2x squared minus 5x plus 1 is equal to 0. I'm just doing this example for the sake of showing how we actually use this formula if you never did this before. So you take the coefficient, which is the number a is going to be the square term coefficient. So a is 2, and then b is the coefficient of the linear term, which is -5, and c is the constant term, which is 1. As soon as I have this, I can apply my formula. It says minus b. So make sure you place a minus in front, so which is going to be minus of -5. Okay, and then so in this formula, since we have the common denominator, so we can write whole fraction divided by 2a, which is the same thing as this one. Sometimes writing separate, sometimes together is better, but I'm going to combine those. And then b squared is -5 is b, and then that square minus 4 times a is 2 in my case, and then c is 1. So that should be under square root. The whole thing is divided by 2a, 2 times 2. Okay, the rest is just simplification. This is going to be a positive 5, right? So I can just say, and then this is 25. 25 minus 8, that's 17. So 5 plus root 17 over 4 is one solution. 5 minus root 17 over 4 is the second solution. You can split this plus and minus to get those two solutions. Since I don't have much space left, so I'm going to just say it and leave it, okay? But that is how you apply the quadratic formula and simplify those expressions to get your final simplest version of the solution. And I hope that makes sense. This is how we get the quadratic formula by using completing square. And this is just one example of it. And then I hope you will practice this so to get better on these, okay? So, and see you next time.